Silviculture, Changing World, The Future of Mangroves. I will be discussing mangrove forests and their global distribution, looking at their ecosystem services and any threats posed to these forests, how these can be mitigated through silvicultural systems, and whether there's a future for these mangroves. Mangroves are a taxonomically diverse group of tropical trees and shrubs which grow within the intertidal zone. As halophytes, they thrive in salty conditions. 54 species are found in 16 families recognized as true mangroves. There are major controls on their distribution: climate, salinity, tidal fluctuations, sedimentation, and wave energy. The majority of mangroves occur between the latitudes of 30 degrees north and 30 degrees south. There are two centers of diversity: the eastern group containing a much larger diverse population of species, when the western group contains a lot less. The value of ecosystem services provided by mangroves is diverse and numerous, and it's also important to really appreciate the roles in which they play both locally and globally. It has been estimated to be worth $186 million each year. The scale of deforestation and degradation is severe. They once dominated 75% of the world's tropical coastline. However, the area of mangroves has decreased by 35% in the last 2 decades of the 20th century, despite our growing awareness and understanding of their roles. It is estimated that within the next 100 years, these ecosystems may completely disappear. Silvicultural systems. Previous and current practices. With the exception of Asia, most countries don't have any systematic silvicultural or management processes in place, and it is such countries where mangroves are being continuously harvested at a level that's just not sustainable for both fuel wood, construction, thatching material, and other things. However, it's not only confined to subsistence small-scale harvesting, it also occurs on a commercial scale. Rising sea levels have been said to be the greatest threat to mangrove forests. They are already likely to be taking place, and climate models project their rate to accelerate. The projections for global sea levels to rise towards the end of the 21st century is 0.18 to 0.59 meters. Mangrove forests require stable sea levels and are extremely sensitive to this rise. The increased frequency of flooding and erosion may impact their ability to naturally regenerate. Mangrove zonation. Species distribute themselves across the intertidal zones and create zonation patterns. What I really want to show here is the differences in mangrove species which are typical of each zone and how they interlink and play a role. And with the impending sea level rise, what effect will this have upon this species diversity? The importance of zonation has been determined by inundation frequencies, which are controlled by tides. Tidal conditions, if altered, may affect the growth and survival of trees. Experiments to simulate the effects of inundation due to sea level rise were taking place using Rhizophora mangle. The results showed that the seedlings, which were in conditions where there was an increase of 16 centimeters imposed on their normal tidal water levels, were 10 to 20% smaller than their controlled counterparts after 22.5 years. Historically, mangroves have been able to respond to the rising sea levels, dating back 65 million years. Just like their environments, they are highly dynamic and not static entities. This research has shown where mangroves were able to respond to the rising sea levels, died back to create a lagoon, and regressed landwards. Once the sea levels fell, they were able to re-establish this land. The restrictions on mangroves' capacity to migrate landwards, however, are huge. The land availability and population growth impede their ability to respond. So what can be done to mitigate these threats, both immediately and in the future, and what role does silviculture have in protecting these ecosystems? Silviculture has been continuously emphasized as being one of the most important factors for restoration projects due to their ability to generate production of timber, wood chip, charcoal, and fuel wood. The most immediate value and emphasis is naturally placed on wood production, and this offers the potential for alternative and more lucrative livelihoods to local communities in place of clearing land for aquaculture and agriculture. An example of successful sustained management is that of the Mantang Mangrove Forest Reserve in Malaysia. Managed since the beginning of the century for timber production, their plan is currently a 30-year rotation period with 2 thinnings at 15 and 20 years. The success of this has directly been attributed to the government commitment and good relationship between businesses and local communities. As shown in this diagram here, the map identifies the area of forest which is being managed and the different locations. Generally, there are different proposed zoning criteria for mangrove forests, and I'm focusing here on production forests, areas where there is the potential to provide approved goods and services. Mangrove forests can be managed for production of firewood and other timber products. Species selection and composition. Not only do you need to choose your species, but you need to choose your site. Not every site will be capable of growing mangroves or restoration, and it's important to understand that the species will only be able to grow in certain places in the world. Maintaining and restoring biodiversity are always goals, and zonation patterns where there are a mix of species may allow for this. Encouraging mixed species plantations will be difficult, however, if the knowledge and tools are in place, this may be successful. Is there an opportunity for different provenances or origins to be selected in order to mitigate damage of crops? The forest systems which naturally occur are that of mosaics and patches, and it's important to try and replicate this in artificial circumstances. Seed propagation. Identifying where you will get your seeds from. Are they going to be nursery grown, or will you aim to directly sow them? There are pros and cons for both, as well as risks. However, directly sowing may produce satisfactory results if sown pre-germinated seeds. You need to also take into consideration pests which may attack and infest your newly planted reserves. Forest tending. What will your thinning regime be? A successful project used a 30-year rotation with a single thinning at age 15. Forests are capable of self-thinning. This can occur through natural processes such as lightning strikes, bolts, storms, and other factors. Disturbance regimes. Will yours be a small-scale and frequent disturbance or a large-scale infrequent disturbance? There is a need to understand the gap dynamics and the phase in which succession occurs, whether or not you will need weed control to protect your newly sown species. Timber harvesting. So your selection system is important when creating canopy gaps. As mangroves are mainly pioneer light demanding species, your objectives are to closely replicate natural disturbances, and you can aim to do this by encouraging natural regeneration of your harvested site. Selection systems are currently taking place in Pakistan, India, Bangladesh and Myanmar, where trees greater than a predetermined diameter are being harvested annually at stipulated coops. Frame trees are being preserved and left on site, and these are for seed production. They may be based on location and the tree's seeding capacity. Modifications of these selection systems are taking place in Indonesia, where no felling zones are being created along coastal and river banks. This is important because these sites are the most difficult for successive regeneration due to the tidal waves. Extraction techniques. You must strive for minimal damage to your remaining seed trees, exposed root stems and the substrate. Erosion will limit the capacity of successive regeneration. Therefore, carrying out timber manually, using cable wires or floating wood out on boats is the best option. Regeneration management. Planting is generally the preferred route. Success, however, is difficult. If time permits, natural regeneration should be the chosen path. Natural replenishment requires sufficient undisturbed forests to reside nearby to act as sources of seed stock. A project retained 40 Rhizophora, Gregaria and Cereopsis trees as shown, greater than 20 centimeters in diameter and a distribution of 17 meters per hectare. The ability to do this allowed a mixed species diversity as well as the opportunity for seeds to propagate and take over areas and gaps in between. In order to learn from successes and failures, monitoring must take place, identifying when, what and how often, if you monitor temporary or permanent plots, what your objectives are, how you feedback information to policymakers and local stakeholders, and make adjustments accordingly. What is the future of the mangrove forests? Well, it's not so bleak. They will depend upon the technological and ecological advances in multi-species silviculture, genetics, forestry modelling. However, the greatest hope for their future is for the reduction in human population growth. In conclusion, change is inevitable. What we really must focus on and pay attention to is the current situation, of which mangrove forests are being mismanaged in an unsustainable fashion. We must aim to enforce and implement sustainable strategies for timber production, adapt those successful techniques that are currently taking place, and also place importance upon the interdisciplinary approaches and those which involve governments, stakeholders, and local communities to secure the future of our forests.